All right, let's just dive right into this explainer and uncover the two massive, unseen engines that secretly dictate our planet's existence. You know, when we wake up every morning, step out of bed, and trust the solid ground beneath our feet, it all feels incredibly permanent, doesn't it? We look outside, we see vast oceans, towering mountains, the sky above, and it just looks stable. But what if I told you that the reality of our world, the very illusion of all that stability, is actually defined by immense, totally invisible forces working frantically behind the scenes?
We really tend to think of Earth as just this solid rock quietly floating through the void. But the truth is, our daily lives, our biology, the safety of our entire environment, they're all governed by dynamic, downright violent forces. And these stretch from a molten core deep beneath our feet all the way out into the dark vacuum of space. These forces are entirely invisible to the human eye. Yet, they are the fundamental reason we have a thick atmosphere to breathe, a stable climate to build our civilizations in, and even the predictable 24-hour day that we base our entire lives around.
So, in this explainer, we'll be covering 1. The invisible engines, 2. Earth's magnetic shield, 3. Battling the solar wind, 4. The gravitational dance, 5. Tides and shifting time, and finally 6. A delicate, changing balance.
Section 1. The invisible engines, the twin forces shaping Earth. Let's start with the first invisible engine, which is roaring directly beneath our feet.
To truly understand the calm surface of our world, we have to look thousands of kilometers straight down, past the crust and the mantle, into complete and utter darkness. Deep within the Earth, intense heat escaping from the inner core causes a massive, liquid metal ocean of iron and nickel to continuously churn and boil. This incredible subterranean storm is what scientists call the geodynamo. I want you to think of it as a colossal, planet-sized electromagnetic engine. The constant swirling motion of these metallic convection currents generates massive electric currents. Those electric currents, in turn, project a vast magnetic field that bursts out from the Earth's interior, pierces right through the crust, and extends tens of thousands of kilometers out into deep space.
Section 2. Earth's magnetic shield, our invisible planetary armor. Now, the crucial point here is that this geodynamo isn't just some scientific curiosity happening out of sight and out of mind. It's the very shield that keeps every single living thing alive on the surface. To really grasp the literal life or death stakes of our magnetic field, all we have to do is compare our thriving home to the barren, desolate landscape of Mars. It shows us exactly what happens when one of these invisible engines just dies. Earth's active geodynamo acts as a colossal protective bubble, known as the magnetosphere. It's constantly deflecting highly energized charged particles, which allows us to safely hold on to our atmosphere and our delicate ozone layer. But look at Mars. Calculations show that billions of years ago, Mars actually lost its active geodynamo. Its core cooled down, the churning stopped, and the engine essentially shut off. Without that magnetic shield, the planet was left completely defenseless, and severe space weather literally stripped away almost its entire atmosphere. That's what left it as the frozen desert we see today. Before we get into exactly what this shield protects us from on a daily basis, I have to share a truly mind-bending fact about how we navigate it. Because opposite poles attract in physics, your compass needle's north end is actually pointing toward Earth's magnetic south. Historically, human beings named the North Magnetic Pole based purely on geography, just because it's up in the north. But from a strict physics standpoint, the magnetic field lines actually plunge downward into the Earth up in the Arctic. That makes the geographic top of our planet the actual south pole of Earth's massive internal bar magnet. Wild, right?
Section 3. Battling the solar wind, fending off the sun's wrath. Let's see how this shield performs when it is violently tested, because it is definitely not a peaceful environment out there in our solar system. Every single second of every day, the sun is constantly blasting us with solar wind. We're talking about a relentless stream of charged particles traveling at the unimaginable speed of up to 1,000 kilometers per second. Just think about that speed for a moment. If this high-speed plasma were allowed to reach our lower atmosphere, it would erode it completely and irradiate the surface. But thankfully, when it hits our magnetosphere, it's abruptly slowed down and diverted at an invisible boundary called the bow shock. This safely deflects the absolute worst of the sun's wrath completely around our planet, kind of like a boulder deflecting water in a fast-moving stream.
However, our armor isn't entirely impenetrable. When the solar wind overwhelms our magnetosphere during massive solar eruptions, the resulting space weather can severely disrupt our modern way of life. Take the Carrington event of 1859, for example. That was a storm so incredibly powerful it induced rogue electrical currents that actually shocked telegraph operators and set their telegraph paper on fire. Or, looking closer to our era, the 2003 Halloween storm damaged over a third of NASA's highly advanced satellite fleet. Everything from our GPS and internet routing to our global power grids is entirely at the mercy of how well our invisible magnetic engine holds up against these cosmic storms.
Section 4. The Gravitational Dance, our tumbling partnership with the Moon. Now we transition from the magnetic shield to our second invisible engine, the gravitational tether connecting us to our closest celestial neighbor.
We are all taught in grade school that the Moon orbits the Earth, but, that's not quite true. The Moon doesn't simply orbit a stationary Earth. Rather, the two bodies tumble end over end around a shared center of gravity called the barycenter. Because Earth is roughly 81 times more massive than the Moon, this balancing point is actually 4,680 kilometers inside the Earth. So as the Moon swings around us in the sky, Earth is actually wobbling in space. We're tumbling around this internal point like an unbalanced dumbbell thrown across a room.
And where did this heavy tumbling partner come from? Well, this incredible gravitational partnership was born out of a catastrophic collision billions of years ago that literally threw pieces of Earth's crust into the void of space. Detailed analysis of lunar rocks brought back by the Apollo missions reveals oxygen isotope ratios that are identical to Earth's, but the Moon notably lacks a large iron core. This perfectly supports the theory that a Mars-sized planet smashed into a young Earth 4.5 billion years ago. It blasted lighter crust material into orbit to eventually form the Moon, while the heavy iron remains safely trapped in Earth's core. And as we learned earlier, that heavy iron is exactly what fuels our geodynamo and powers our magnetic shield today. It's all just brilliantly connected.
Section 5. Tides and Shifting Time. How gravity acts as a planetary brake. Let's dive into how this tumbling gravitational dance exerts a physical pull on our oceans, creating the tides and fundamentally altering the passage of time itself.
This creates a fascinating phenomenon known as tidal braking. First, the Moon's gravity pulls forcefully on our oceans, creating massive bulges of water on either side of the planet. But because Earth spins on its axis faster than the Moon orbits around us, our planet's rapid rotation actually drags those ocean bulges slightly ahead of the Moon's position in the sky. This sets up a relentless gravitational tug-of-war. The Moon pulls back on those advanced ocean bulges, creating friction right across the seafloor that is literally slowing down our planet's spin. And as a physical reaction to this braking force, the Moon is slowly stealing our rotational energy. That means it's drifting further out into space by about 1.5 inches every single year.
The proof of this slowing rotation is permanently written in stone. Fossilized corals, which grow daily bands much like tree rings, prove that because Earth used to spin much faster, a single year once contained roughly 400 days about 400 million years ago. The Earth has been slowly tapping the brakes ever since. Eventually, in the incredibly distant future, Earth's spin will slow down so drastically that the length of a single day will be exactly equal to a month, and one side of Earth will permanently face the Moon, locked in a perfectly synchronized stare. But the Moon isn't the only thing messing with our time frames. Interestingly, climate change is now adding 1.33 milliseconds per century to the length of our day. As massive polar ice caps melt and global sea levels rise, the staggering mass of the Earth's water is redistributing from the poles toward the equator. I want you to picture a spinning ice skater throwing their arms outward to slow down their spin. By moving that heavy mass away from the axis of rotation, this shifting water is further slowing the Earth's rotation at a rate we haven't witnessed in 3.6 million years.
Section 6. A delicate changing balance. The future of our cosmic neighborhood. Bringing this all together, let's examine how this incredibly delicate planetary balance is in a constant state of flux. Absolutely nothing about our world is static. The invisible engines are always shifting. For instance, our North Magnetic Pole is currently migrating at speeds up to 40 kilometers per year. That's so fast that airports actually have to repaint the navigational numbers on their runways just to keep up. Over vast stretches of geological time, the entire magnetic field completely flips. North becomes south and south becomes north. And thanks to the unequal gravitational pull of the Sun and Moon on Earth's bulging equator, our planet wobbles like a slowing top. That means in about 13,000 years, our North Star will no longer be Polaris, but a completely different star called Vega.
And hey, if you think human science can predict exactly how all of this will play out in the long run,
Think again. The combined gravitational interaction of the Sun, the Earth, and the Moon creates what physicists famously call the three-body problem. It's an interaction so remarkably complex and non-repeating that it is mathematically unsolvable in a closed analytical form. Even with a staggering 12,000 new mathematical solutions discovered by researchers recently, predicting the exact long-term future movements of this chaotic three-body system remains one of the ultimate, profound puzzles in astrophysics. Our intuition completely fails when trying to chart it.
So, as we wrap up this explainer, I'll leave you with this lingering thought. The perfectly stable ground you stand on is a beautiful illusion. We are, in reality, passengers on a deeply dynamic, tumbling spaceship powered by mysterious, invisible engines of magnetism and gravity. And given how much we've learned just recently about the chaotic nature of these hidden systems, it truly makes you wonder, what else is secretly shifting right beneath our feet that we haven't even discovered yet? Thank you so much for exploring the invisible engines with me today.